Assalamualaikum warahmatullahi wabarakatuh. We are from Group 13 and today we are going to present the future potential of advanced glass material with the application in biomedical, optical and energy-related applications. And for the group members' introductions, we consist of 4 different group members. The 3 of us are from part 3 and 1 of us is from part 2. And my name is Nur Khadijah binti Haimi from part 3. Before we continue our presentations, we are going to start with a very simple question, which is basically, what is glass? Glass is a special material that is amorphous solid. The molecules are not arranged orderly like a crystal, which is a solid. It is made by heating solid, commonly sand, until it melts and being mixed with other ingredients. And after being melted until 1200 degrees Celsius, the ingredient will become liquid and it will cool down quickly and become hard and glassy. And what makes them very special is that glass is very transparent, highly brittle, transmit light easily, high chemical resistance, and have a high melting point. Next, for our second question, we are going to ask ourselves, how far has glass developed? So here I have stated 2 of my examples. So the first example is a self-healing glass that is found by a group of researchers from University of Tokyo on 2017. The glass has the ability to repair itself after being cracked at room temperature, and it is now potentially used in mobile phone screens to reduce repair costs. And the second example, we have the flexible glass, which the research began since Egyptian and Roman times. It is a glass that bends without shattering like plastic, and it is also used in mobile phones. For our first point, which is the future potential of advanced glass material in biomedical sector, we are going to talk regarding bioactive glass. Bioactive glass is a glass that can bond directly with bone and structurally akin to mineral phase of bone. Bioactive glass is composed of silica, calcium oxide, sodium oxide, and phosphorus pentoxide with variation in composition. Although the glass have poor chemical stability, it has appropriate nanostructure, making it able to communicate with cells and tissues regenerations. And the type of bioglass that exists today is borate-based, and germanium-based. And for the future potential in design and fabrication of the glass itself, until today, the potential in fabrication is a self-repair, bioactive glass ceramic scaffold structure using 3D printing method. When a crack appeared on the material, the self-healing property of the material and regeneration of bone tissue will release calcium and phosphate ions that will stop crack from spreading and triggers the body to regrow new bone tissue. This process is caused by microscopic capsules that contain calcium polyphosphate that are embedded in material. As until today, bioactive glass has been used in 3 different medical sectors. So the first sector, we have dental, which is in dental, bioactive glass is being used in products which is toothpaste, and also used in treatments such as root canal treatment and pulp capping. And for the second sector, we have bone treatment, where bioactive glass is being used in bone healing, nerve and muscle regenerations. And the last one, which is the third sector, we have cancer treatment, which is bioactive glass is being used in cancer therapy, antibiotic delivery, and also bone healing.
Hi, my name is Nur Hidayah. So I will explain the future potential of advanced glass materials in optical. Application through transparent solar photovoltaic glass, or we call as TSPV. So TSPV is a transparent solar photovoltaic technology that converts absorbed light into electricity. Why? it's allowing visible light to pass through the glass. This means the glass can function as both a window and an energy generating device. So, there are two main approaches used in this TSPV technology. The first is visible light absorption, and the second is the luminescent solar concentrator, or we call as LSC. Um, so the future potential of TSPV is very promising because it is considered a cutting edge technology for renewable energy generation due to its transparency and multifunctionality. It can be integrated into windows, buildings, vehicles, and other glass-based structures without affecting visibility. So therefore, TSPV has great potential to support sustainable energy production while maintaining the normal function of glass materials. Next, they also have several future optical applications of advanced glass materials. First, advanced glass materials can improve optical communication system. For example, advanced optical fibers are capable of transmitting larger amounts of data with greater reliability compared to conventional communication systems. Improved glass composition also helped to reduce optical attenuation and signal loss. Second, advanced glass materials support the development of high-power fiber lasers. These materials provide excellent beam quality and thermal stability. In addition, reducing ion clustering helps to improve laser efficiency, making fiber lasers more effective for industrial, medical, and scientific applications. Last, advanced glass materials are widely used in advanced optical sensors. Glass fibers can interact strongly with their environment while maintaining good optical transmission. So, as shown in this slide, the fiber evanescence wave spectroscopy of FEWS technique use infrared light transmitted through an optical fibers to detect the optical signature of a specimen. This allows highly sensitive chemical, environmental, and biomedical sensing applications.
Future potential of advanced glass material in energy related application. So there are three information that I want to share which is related to the future potential of advanced glass material in energy related application. So the first one is solar energy. For the solar energy, there is high efficiency photovoltaic panels, which is the advanced glass that involved in the solar energy. So it function in convert sunlight to electricity. So the advanced glass material is the protective layer of the solar panels, which will allow make sunlight to reach the solar cells. So how the advanced glass materials function in they play role as anti-reflective glass to assure max input sunlight absorbed by solar cells. So there are advantage of the advanced glass material in the solar energy. So the first one is there is excellence in resist with weather and UV resistance. Also they will provide long life service, and the last one is the increased intensity of light transmission. So next one is solid state battery. Alright, so for solid state batteries, so in solid state batteries, it's use solid electrolytes instead of the liquid electrolytes. So it's worked by transporting ion between electrodes. This process occur during charging and discharging, where ions like sodium or lithium will pass the solid electrolytes. So for the solid state batteries, there are several advantages. So the first one is it is non-flammable. they are more safety in chemically and thermally stable. And the last one is ion transfer is more efficient through solid media. So next we proceed to the smart windows. Okay, so for the last information about where the advanced glass material involved in energy related application. So the last one is the smart windows. So what is smart windows? Smart windows is smart glass that they will change their transparency automatically or electrically. So there are two types of smart windows, which is thermochromic and electrochromic glasses. So what is thermochromic and electrochromic? Thermochromic is the smart glasses that will react with heat, while electrochromic is the smart glasses that react with electricity. So these smart windows has advantages. So the first one is it's prevent harmful UV radiation to human. Next is there is energy efficient and will make the building more sustainable. And the last one is it's reduce electricity consumption because no needs use of cooler or heater.
Hi, Assalamualaikum. My name is Nur Fadli Irfan bin Wahid, and for this part, we will talking about the discussion of the advanced glass material. As we all know, advanced glass material has evolved beyond conventional glass and are now widely used in biomedical, optical, and energy-related application due to their excellent transparency, chemical resistance, thermal stability, and ability to modify for specific function. Recent innovations such as self-healing glass, flexible glass, and bioactive glass demonstrate the growing importance of advanced glass in modern technology. As we all know, in biomedical application, bioactive glass is one of the most significant developments because it can bond directly with bone by forming a hydroprecipitate layer similar to natural bone mineral. This property promotes faster bone healing and tissue regeneration, making it suitable for bone implants, dental restoration, wound healing, and cartilage regeneration. In addition, future development involving self-healing bioactive glass and 3D printing technology may improve implant durability by repairing small cracks while supporting new bone growth. However, its relatively low chemical stability remains a challenge that requires a further research. Next, in optical application, advanced glass material play an essential role in improving communication and sensing technologies. Advanced optical fibers provide higher data transmission with lower signal loss compared to conventional fibers, supporting the increasing demand for high-speed communication. Glass fibers are also widely used in optical sensors due to their high sensitivity to environmental and mechanical changes while maintaining excellent light transmission. Furthermore, improved glass composition increase the efficient and thermal stability of high-power fibers laser, making them suitable for industrial medical application. Next, the advanced glass material are also important in energy-related application. Transparent solar glass can regenerate electricity while allowing light to pass through, making it suitable for energy-efficient buildings. It also improves solar panel efficiency and its use in smart windows to reduce energy consumption. In addition, glass-based solid electrolytes make solid-state batteries safer, more stable, and more efficient. Next, a presentation doesn't feel complete without a conclusion. So, in conclusion, advanced glass material has evolved from traditional glass into multifunctional material with significant potential in biomedical, optical, and energy-related application. Their unique properties enable innovation such as improved medical treatment, faster communication system, and more efficient renewable energy technologies. Although challenges such as manufacturing costs and material limitations still exist, continuous research and technological advancements are expected to overcome this issue. Therefore, Advanced glass materials are expected to play an increasingly important role in improving technology, sustainability, and the quality of life in the future. Thank you.